Hi everyone and welcome to this video. This is part 3 of PCB making series at home. In this part I will talk about how really a PCB is made and will make the tuner transfer step, which is one of the most important parts in the PCB production. In the next part I will talk about etching the PCB itself and shape the real copper that will conduct electricity at the end. The video has timestamps made as chapters if you'd like jumping into a point directly. So without any delays, let's get started. Now let's talk in general, but in a bit of details about how really a PCB is made. First, you should know by now that our PCB will be single-sided. That means copper traces that will act as wires to conduct electricity will be on only one side. Other designs might be double-sided, so copper on both sides, but those are insanely hard to produce at home without the special tools needed. Motherboards inside your computer or phone that on it you are watching this video right now might be consisting of a PCB that might have 4 or even 8 layers inside it. That are of course factory made, but you know, me and you are not a factory. You will notice something by now in the PCB you bought or will buy, which is, of course, copper is on only one side. In the other side you might find some fiberglass or plastic. If you had copper from both sides, that means that you bought a double-sided PCB, not a single one. You could still use it, but double-sided PCBs are usually much more expensive. Our whole manufacturing process will be on the copper layer. Now, there are many ways of etching the copper itself and shape it, but the easiest and the cheapest is the way I'm doing, which could have some disadvantages, but we'll talk about those later. Our goal is to print our circuit in the copper. That will be our traces, which will conduct electricity at the end. Your design should be ready and tested. Then somehow you want to cover the copper side of your PCB with your artwork, the traces, pads, even images if you want. So parts which shall be at the end copper should now be covered with some black ink or something like it. Here comes the laser printer part. Obviously, you will not insert your PCB into a printer and wait for it, and here the magic of the tuner transfer happens. Now our goal is to print the final look of our PCB on the glossy paper. You could insert the whole A4 paper onto the printer and print your traces and pads and text if you wish, or to reuse the type of papers. I take a part which might be very big to ensure that the printer prints on it and tape it onto another paper. Then I print my copper artwork, but keep in mind again, what will be printed on this will be flipped. That means on your design the copper will be on the bottom layer while plastic will be up. So when it's printed on the paper it will be flipped. Bear that in mind. Plus, be sure from your printer to print correctly. A small difference in print scale might mean really bad things at the end. I already talked about this problem in the previous part of this series. Of course, print on the glossy side of paper. Here comes the first failure I proudly accidentally had. The laser printer was a bit old, so last month I had replaced the tuner inside it, replacing the original tuner. When I printed this time, print quality was very awful. A lot of parts were not printed and this was really bad. In that case, I would play a lot with print settings, pressure, heat, and many trials until I get it right. But you know what? I'll continue to showcase how to deal with such a bad failure.
Because obviously I can't get a new tuner at the time of shooting this video and I don't have any more glossy paper.
After getting the printed glossy paper, not to mention to print only the copper trace and pads and text only, I know I might not be clear here because there are many PCB designing softwares. I can't just tell you one way which might not work in another software. But in general, in your PCB board design, you will have layers. Disable all of the layers except pads, bottom or traces, and any layer that has text or images that you want to be made with copper. Now the tuner transfer magic. Remember, our goal is to put that ink on the PCB copper side. Now the tuner transfer is a transfer, but it's understandable from its name. The tuner ink on the glossy paper will be transferred to the copper side of the PCB sheet, re-mirroring it back so it will be normal. You know why I told you in the beginning right now. Of course, this process will be by the use of heat using an iron. I prefer to work on ground because for me I don't want to light my wood desk on fire and don't want to shatter any glass table with heat. Now this part might be tricky, but your iron temperature should not be high at all. I know in other videos people might say open your iron and its maximum heat. Well, don't get me wrong, they are great, but based upon my testing in high temperatures and low temperatures, low temperature wins. And by low, here I mean about 120 degrees Celsius, and that's it. Don't go for 200 degrees or 300 degrees Celsius, and we'll tell you the reason in a minute. So you start heating the iron and prepare your clean, shining, bright, ready PCB. Also, cut the glossy paper with the printed ink on it as big as your PCB size exactly, or a little bit tiny bit bigger, but not smaller. And place that paper very softly on the PCB. The glossy side that have the ink will be of course pointing towards the copper side of the PCB. Here you should be very careful. After positioning your paper carefully and ready to transfer, put your iron on the paper and apply force as strong as you could healthily can, without moving your paper even the tiniest bit, because if you did, that ink will shift and bad things will happen. If your PCB is small, you could just put your whole iron base on it. If it's not, apply pressure and heat in all of the PCB parts and be as fair as you could. Continue moving your iron without slipping the paper. Continue applying pressure and heat for really about 6 minutes. That time will depend on how big is your PCB. After that, switch off your iron and put it in a safe place because again, remember, safety ought to be number one in your work. Leave the PCB to cool a bit, then try to carefully peel out the paper. If you really used low temperatures, then you have a very high percentage that the paper will peel off easily. So do that very slowly and carefully. If not, you will have to put it in water for some time, then you could peel off that paper. If you, however, used very high temperatures, plus you overheated a part or continued heating for a lot of time, ink will have some weird artifacts, and some parts might melt with other parts, and again, not very pleasant things will happen. At the end, you should have something that looked like this. In some cases, including my super lucky case, ink might not get completely transferred, which could be because the temperature was too low or you didn't give it much time, but you decide whether to re-clean your PCB, remove the ink, and reprint and retransfer the tuner, which you could definitely do if you don't feel blessed with your outcome, or you could from now proceed to the refining process. Well, as the name suggests, you will refine your PCB. Ink should heavily cover all the parts that should be covered at the end. If you find places where ink was not transferred properly, or parts you scratch accidentally, or your printer did not print them properly, use any permanent ink or pen and with your hand try to fix it. But keep in mind that if you found a lot of artifacts in your PCB, it's just better to retune or transfer rather than spending time refining. And with that, the video is finished. If you have any concerns, tips, questions, and even experiences you would like to share, don't forget to tell me in the comments. I offer all of my contents in Arabic, my mother language, and English. Don't forget to subscribe, and see you next time.